In this video, we will understand how to use the quadratic formula to graph a quadratic function. The skill you will need to understand the video, of course, are knowing the quadratic formula, understanding the vertex form of a quadratic equation, understanding the various features of a parabola, and using the store function of your calculator. Let's begin. So if you're given a quadratic equation in standard form, so f of x equals ax squared plus bx plus c, you know that if you want to solve the equation f of x equal to 0, for example, when you want to find the x-intercept, then you will have two solutions. X equals negative b plus or minus square root of b squared minus 4ac over 2a. This is called the quadratic formula. Now, please remember, this equation does not always have solution. We'll talk about that later. I have a sum of two terms at the numerator. Therefore, I can break this fraction into the sum of two fractions. The first term is negative b over 2a plus or minus square root of b squared minus 4ac over 2a, right? So why did I do that? Well, to answer this question, let's take a parabola and let's make it cross the x-axis in two x-intercept right here. So again, this expression gives me the value of both x-intercept, this one and this one. What I like about it is that it's symmetrical, right? You go to negative b over 2a, and then you add or subtract the same quantity, right? So what does that mean? It means that negative b over 2a is in the middle of my two x-intercept, right? This has to be negative b over 2a. And then I add square root of b squared minus 4ac, and then over 2a, and then I will subtract it to find the other minus square root of b squared minus 4ac over 2a to find the other x-intercept, right? So negative b over 2a is in the middle. And by the way, this is true even if your parabola does not have any x-intercept. This quantity right here, the middle, is negative b over 2a. Well, there's no middle here, right? Because you don't have any x-intercept. But what do I mean by when I say middle? I mean the x-coordinate of the vertex. That's it. Negative b over 2a is the x-coordinate of your vertex, okay? So the quadratic formula allows you to find the x-coordinate of the vertex. If you look at the vertex form, f of x equals a, it's the same a as this one, times x minus h squared plus k, then this h right here is negative b over 2a. Okay, so you need to know how to use this formula. But now the question is, how do you find the k? Well, h is an input, it's an x value, right? So to find the k, k is a corresponding output. Look at the graph, right? If my input is negative b over 2a, which is h, this is h right here, right? H is negative b over 2a. The output is going to be k. So I just want the output. How do you find an output? Well, you plug the input, negative b over 2a, in the function to find the output. And this is how you're going to find your vertex. And this is k right here, okay? Let me show you with the calculator. It is very simple to use that, all right? So let's take the calculator and let's practice this. All right, here is the first example from your notes. So what is negative b over 2a? So again, guys, I'm going to use my calculator, okay? A is 1, B is negative 8, and C is 6. Okay, so let's store these values in the calculator. So 1 stored in A, negative 8 stored in B, and 6 stored in C. So again, you need to know how to store these values. Here we go. And so now I'm going to type negative b over 2a. So negative b I could do it by hand, but I'm going to use this on my calculator, okay? Divided by, careful right here, if you just type 2a like this, then you're going to divide by 2 and then you're going to multiply by a, okay? So you need to open a parenthesis. So let me insert an opening parenthesis and let me close it. You must have the parenthesis, okay? So what is that? That's 4. So let's go back to this and let's write, well, this is just 4, okay? So now k is just h, I call the function h, right? H of negative b over 2a, which means h of 4. So let me show you how to do that. I'm going to take my calculator again. Let's open the y equals menu right here, y equals. I already stored a, b, and c, right? So I'm just going to type ax squared plus bx plus c. And right here, it does, when I'm going to change my stored value for a, b, and c, I won't have to do anything to y1. It will be ax squared plus bx plus c, okay? So let's go back to the home screen of the calculator, second quit right here. And now I want to do y1 evaluated at the point negative b over 2a. So here's what you do to type y1. Check it out. I go to alpha trace, and I have y1 here. So enter. Here we go. Now, if you do not, some of you have a TI-83 and you don't have the capability of doing alpha trace. So let me show you what to do if you cannot do that. So let me clear this line. All right, so if you don't have this possibility, here's what you do. You do vars on your calculator, it's right here, vars. You go to y vars, so let's move to the right, y vars, function, and then you have your y1 right here. So it is a little bit more clunky this way, but it works, okay? So again, you would be going to vars, y vars right here, function, so I want enter, and then I want enter right here, okay? So again, let me clear that and let me go with my alpha trace much faster, y1 enter. So y1, open the parentheses, and my input is negative b over 2a. So let's grab negative b over 2a right here, enter, and let's close the parentheses, and that's it, y1 at negative b over 2a. Let's frac this just in case it is not a fraction. Before I push enter, I'm going to frac it, and I have negative 10. Here we go, right? So that was pretty painless, right? So k is negative 10. And so I know the vertex form. The vertex form is, so h of x is a times x minus h squared plus k. So in this case, a is 1, right? So it is h minus 4 squared plus k. That means minus 10. K equals negative 10. Here we go. Let's go over a second example. Okay, so this is example 3 from your note. It is going to be faster because most of the thing I need is plugged in my calculator. For this example, I just need to enter A, B, and C, right? So A is 3, B is 12, and C is also 12. Okay, let's go and take the calculator. So 3 stored into A, here we go. 12 stored into B, like so. 12 stored into C, like so. All right, so now I'm just gonna grab what I need, negative b over 2a. I've already entered it, right? Where is it? Right here. So negative b over 2a, enter, negative 2. Let me also now grab y1, right? I've already entered y1 as ax squared plus bx plus c, enter. And what is, so negative b over 2a is my h, and this is my k, right? Okay, so negative 2 and 0. All right, so this is negative 2 and this is 0. So my vertex form, the function is called k. K of x equals, so a is 3 times x minus negative 2, so x plus 2 squared, and then plus 0, so I'm not going to write it. That's my vertex form. And from there, I can study my parabola, right? Okay, do I have another example? Yes, I do have another example for you. So let's go again. Let's enter A, B, and C. So in this case, A is -3, B is -4, C is -2. Don't wait for me. You can pause the video, do it on your own, and see if you find the same vertex form that I'm going to write. Go ahead. All right, let's check it out. So -3 stored in A. Here we go. -4 stored in B. Okay. And -2 stored in C. Very, very quick. My Y1 is already loaded with what I want. So let me just get these two expression. Here we go. -b/2a. That's my h. Oh, I should have frac that. So frac right here. I should have entered frac right away. So it is -2/3. And now let me go and enter the other one that I've already entered right here. It may be easier just to type it directly. And this one is already gonna come out as a fraction. And it's also -2/3. Okay, so we have h equals -2/3 and k is also -2/3. So what is my vertex form? My vertex form is L of x equals -3 times x minus -2/3, so that's plus 2/3 squared minus 2/3. Here we go. So we're done with these first examples, how to use the quadratic formula to write your equation in vertex form. So in this case, you don't need to complete your square. Using the calculator with the store function, with the store ability of it is a great thing. Let's move on to the next part of the lesson. In this part of the lesson, I'm going to be looking at what we call the discriminant of a quadratic function. So what does the quadratic formula tells you about the equation? So suppose you want to find the x-intercept, for example, or you just want to solve the equation equal to 0, then you can use the quadratic formula and you have -b plus or minus b squared minus 4ac over 2a. So first of all, let's define what we call the discriminant. This quantity right here under the radical b squared minus 4ac is called the discriminant of the equation, of this equation right here. And actually, we often use the Greek letter delta. This is delta right here. Delta for a quadratic function means b squared minus 4ac. So what does the discriminant tell us about the equation? Well, your equation may have two solutions, right? Like this, for example, or it may have only one solution, like this, one x-intercept, or possibly none. So for example, in this case, I wouldn't have any x-intercept, right? So how do I see that? Well, the discriminant is gonna tell me how many x-intercept or solution of this equation my quadratic function will have. So what does it mean in the first case that the equation has two x-intercept? That means this square root is well defined, right? And you will have your 2x-intercept from the plus or minus here, right? So that means that b squared minus 4ac is strictly above 0. So the square root is well defined, okay? What does it mean in the second case that the parabola only has one x-intercept? So in this case, I don't have two plus or minus, like two different signs to give me two different solutions, right? I only have one. Which one is it? Well, actually, we know what it is. This is the x coordinate of the vertex. So this is h equals -b over 2a. So that means the discriminant is equal to 0. Okay, there's no discriminant. It is equal to 0. So in this case, we have b squared minus 4ac equal to 0. Finally, in the last case, so let me erase that. What does it mean that there is no x-intercept? That means that this root is not a real number. I don't have any x-intercept, right? That does not exist. The whole equation does not exist. So the root does not exist. So it means b squared minus 4ac is negative, strictly smaller than 0. It is negative. I have written all of these results in my note. Let's check it out. Okay, so you see right here in this table, you have the various results. So in this first row, A is positive, so all of my parabolas are concave up, concave up, concave up. In this case, B squared minus 4AC, the discriminant, right, delta is above 0, so I have two x-intercept. In this case, delta is equal to 0, so I only have one x-intercept. And in this case, delta is negative, so I have no x-intercept right here, right? And it's the same result for the second row, but in this case, I've looked at parabolas that were all concave down, so two x-intercept for delta positive, one x-intercept for delta equal to 0, and no x-intercept for delta negative. Folks, you need to know these results about the discriminant, okay? Let's go over some example now. So I have two sets of example for you. In the first set of example, I'm asking you just by looking at the equation, to determine how many x-intercept this equation will have, right? So what is the value of A? A is 1, B is negative 6, and C is 9, right? So delta, which is B squared minus 4AC, is equal to B squared, so negative 6 squared minus 4 times a1 times C9. Now again, I can easily do that by hand, right? But if you want, you can take your calculator to compute that. I'm going to do this one by hand. It's not a big deal. 36 minus 36. Oh, delta equals 0. So if delta equals 0, if you look at the table above, that means you have only one x-intercept. One x-intercept, and that would be your vertex, right? Okay, let's move on to the next example. Okay, here's the next example. So A is negative zero point 0.5, B is 2, C is negative 4. In this case, I'm not going to bother. I'm going to take my calculator. So let's take it. So negative zero point 0.5 stored in A, 2 stored in B, negative 4 stored in C. All right. Okay, I need b squared minus 4ac, right? So b squared minus 4ac. So what is that? This is negative 4. All right. So in this case, delta, which is again b squared minus 4ac, what you put under the radical of the quadratic equation, is equal to negative 4. So it is negative. So what does that mean? It means you have no x-intercept. So I can tell you actually, look at the concavity. That means my parabola is going to be somewhere below the x-axis, maybe here, maybe here. I don't know where, right? But somewhere below the x-axis, and it doesn't touch it. Okay, let's go over the last set of examples. All right, guys, these are matching problem, but you're going to see that actually these matchings are a little bit trickier than the matching we've had before. For example, look at number 9 and number 13, right? 9 is telling you that the parabola is concave up and the y-intercept is plus 6, concave up plus 6, okay? And 13 is also telling you the parabola is concave up and the y-intercept is 4. So there's no way for you to determine which one is going to be. It could be D or it could be E, right? How do I know? So I need another way to look at these equations to be able to determine which graph it is, okay? So let's start again. Okay, here's what I'm gonna do. I'm gonna look at the concavity, of course. So I know this is conc up. I know this is conc down. This is, you know what, I'm gonna turn. I know this is conc down. I know this is conc up. This is conc up, and this is conc down. Okay, all right. And then what else I'm gonna look at? I'm gonna look at my discriminant. Delta equals b squared minus 4ac. So this is negative 4 squared minus 4 times 1 times 6. right? So this is negative 4 squared is 16 minus 24. So that is negative. So this is a parabola that is concave up and delta is negative, so it doesn't have any x-intercept. So concave up, no x-intercept, well, that's E, right? Concave up, no x-intercept, that's E. So I have 9 that goes with E right here. What about 10? Again, let's check out delta. B squared minus 4AC, negative 4 squared minus 4 times A times C. So this is 16. Two negative sign make a plus. 16 plus 24. I don't care what the number is, I know it's positive. So I'm looking for a parabola that is concave down. Delta is positive, that means you have two x-intercept. Concave down, two x-intercept, right here. That's this one, right? That's the only one, right? Concave down, two x-intercept. So it is A. So this is A. Okay, what about this one? Delta is B squared, 4 squared minus 4 times A times C. Oh, be careful with all these negative signs. So this is 16. 1, 2, 3 negative signs, so it's going to be negative 24. That's a negative discriminant, negative delta. So concave down, no x-intercept. Concave down, no x-intercept. This one right here, F, concave down, no x-intercept. So 11 is F right here. Okay, so you see, oh, I said A for this one, right? Yeah, I said A. All right, let's finish the last three equations and we're done with this video. All right, so what do we got here? We got B squared minus 4 A is 1, C is negative 6. So this is 16 plus 24. So it is positive. So concave up and 2 x-intercept. I got it right here in front of me. That's B. Concave up, 2 x-intercept B. For the last two, well, that's easy, right? One is concave up and the other one is concave down. So let's check out the two parabola I have not selected. Oh, right here, C. C is concave down, so that's got to be this one, C. And if you look at the discriminant, then the discriminant better be 0, right? 13 is concave up, so which one I have not selected? I haven't selected D right here. That was actually D. So this is D, okay? I hope the lesson was clear. Thank you for watching.